All right. Sorry about that. I just had a pretty important phone call there, so needed to take that.
Was it from the one of the agencies, the alphabet agencies?
Yes, yes, it was from no. Open up, open up. Okay. They're banging down my door. Oh my gosh. How you been, my friend? How was your week? Or a couple weeks, I should say.
Uh, all right, I guess.
Oh, sounds like kind of a bummer. Switch over to the. Yeah.
Switch
There we go.
over that.
Hmm.
I even got
Tastes like victory.
a. I even got a bigger notebook.
Oh, got a bigger notebook? Okay. Were you able to digest the material okay?
I
Was it
I
was it easy?
think so. The only thing, the only thing I guess I was maybe confused about is some of the maybe rules for working with the negative numbers.
Okay, so are you talking when you're talking about that, you're talking about just like negative and negative is positive and things like that, or division and things like that?
Yeah, I guess it would be some most those like some of the homework questions had like I need to write them down next time I think when I go over it which one it was.
Okay.
Like maybe
If
it
you need to
was
ask me any of the homework questions, you can certainly ask and we can go through it. That's fine.
okay. Yeah, no, I got them all eventually once I once I did it a few times.
Did you go through the little help menu, like help me
Yeah.
solve this or yeah. Sometimes those are pretty helpful. So a lot of people reference those so that way they can guide through it little by little. Um, Hopefully the notes were also very fairly helpful for you. So that's at least that's the goal anyway.
Yes. That's good.
Yes. Look,
Uh,
I understand I'm dumb as bricks, so I try my best to
well,
not be as dumb as bricks.
at least you understand numbers, and that I certainly don't. I'm gonna put my phone right in front of me. Wait a minute. Maybe if I use no, okay. I'll just keep using my phone. That's fine.
How's Aya? You there? Can you hear me?
Yes, I
Okay.
absolutely
Uh,
can.
Sorry, I was just asking how Aya was doing.
Oh, yeah, no, no, she's great. Well,
Cool, cool.
she's at work now.
Yeah, yeah. Figure on a Saturday morning she'd probably be at work. I don't know how many people are outside at the moment though. Pretty sure
Probably a
most of
lot.
Tokyo's.
I don't know.
Really?
People
Just
people
Tokyo? I
here
thought.
are not quite so smart. You would think
Really?
that
I
they would
thought
be, but they're not.
I thought everybody would be it'd be like a ghost town like it is in other places.
No,
I mean, hmm,
it is not.
I know a lot of people drive around here, but that's only to get places. Really, there's no. Hey Jade, how's it going? Um. Yeah. So I mean, it's kind of weird. Some people are a little bit passive about it. Some people are pretty strict about it. I'm trying to keep indoors so I'm not spreading stuff. But I go outside. I wear a mask. Pretty simple. Can't
Yeah.
be that hard.
No, no.
Wearing a
It's
mask
it's
outside, right?
really it's really easy, and a lot of people here don't. My thing, especially, is when people are on bicycles and they're like, "Oh, I'm on a bike." That automatically protects me from coronavirus, so I don't have to wear my mask because I'm on a bicycle.
Wait, the bike magically has an aura shield. It has an aura shield like a +2 defense, and then you suddenly get a special effect like a
Yeah.
Yu-Gi-Oh card. Holy crap, man!
Apparently, you get epic warding from having
Epic warding
your bicycle.
negates all poison damage. I see how it is.
Yeah,
See how it is.
contagion no longer has any effect.
Oh, I see. I see how it is.
No,
I see how it is.
no, I don't think you do, because you are able to use your functioning human brain.
Oh, functioning human brain. I didn't remember. I remember the last time I had that. It was yeah, I don't even remember actually now that I think about it. Functioning human brain. Oh, that's a rough one for me.
Yeah. Do you remember
Yeah.
that? Was it Happy Gilmore? No, not Happy Gilmore. The Water Boy, where you have that guy in Louisiana who's talking about how people are like wasn't born with a fully functioning brain. Even
Yeah,
that
yeah.
guy would wear a mask,
That's true. He would actually.
and yet, people don't.
You can't win them all, my friend. You can't win them all.
No,
That's just how it's going to be. You
but
can't win them
do
all.
you think the Darwin Awards site just like it just crashed because of all of the submissions for 2020? It just
I
like
think uh
it
I
died,
think that's
all
true.
of it. It just the server farm it was housed in just went up in flames because it couldn't handle the load.
Do you think that still measures up against the guy? He was like a Darwin Award winner where he basically strapped a jet engine to the roof of his car, put it on the salt flat, and, and basically crashed himself into a mesa. If it's on that level, then okay, I'm gonna run with it. I'm gonna run with it. Oh my gosh, because I still remember that story from. I still remember that story. Milky, thanks for the raid. Oh man, it's funny. Milky with the raid. Respect, Milky. You guys are awesome. Wait, you ready to get started, Tony?
What's that?
Ready to get started?
I am ready to get started. I'm ready to go.
All right. Now I'm going to ask you a quick question here because it's been a couple weeks.
Yeah.
But do you want me to do another example of the AC method here? And then
AC. Oh
we
wait,
can.
I need to get my
This,
second notebook. I
oh, that's fine. Yeah, it was from the last. It was from the last go round. So
I
it's kind of.
I got I
I'm
wrote
just.
I rewrote everything
Mhm.
in two notebooks just so I could make sure that I was on top of everything. Yeah, multiply A times C.
Right. Do you? I was going to show you. Like I know we ended off there last time, but I
Yes.
was going to show you if you want me to show you another example of that. I can show you another example of that with different numbers because there could be possibly different looks to the problem.
Okay.
Hence why I'm asking you. If you don't want me to,
No, no,
I'll
sure.
skip to the next question, but I can show off that really quick and then we can move.
Yeah, let's go.
Um,
Let's do some review on
okay.
that one. Why not?
Excuse me, man. Super dry in my apartment, so I apologize. All right. So let's quickly do this here, and which one do I want to do? All right, let's do that. Okay. So the one I'm going to do here, I'll bring it up on the paint tool, is making money every day. All right. It's my. Okay, so here's the example we're going to do here, Tony. We're going to do, yeah, this one. So 4x squared minus 13x equals -3. Okay.
Yes.
So, all right. So let's go through this carefully here. Now, the reason why I want to set this problem up here first, that kind of looks like it looks very different than the one we did last time. But this does have some important implications for what we're going to be doing here for the other questions. and also we're actually going to talk about functions here today as well. Okay, so I know that we've been kind of skirting that topic there,
Okay.
but we want to talk about that in a more formal sense because now I think you have the setup to work with functions with these 3 questions that we'll go over. Okay.
Sure.
In in any case, uh, the way we're going to apply the AC method is we cannot apply the AC method unless we move everything over to one side. So for us to do that here, what we want is, this is what we want, right? In some of these examples here, what we want is that we want it equal to 0. Because if it's equal to 0, then we can apply that factoring technique. If it doesn't equal 0, I'm going to have a lot of problems. We're going to have sad days, okay?
Okay.
Lots of sad days.
No sad days.
Yeah, I mean, I know you have your coffee cup slash, Coffee Max next to you that you bought from the vending machine around the corner. But, yes, we're not going to have your tears fill that up again, okay? That's very important. I do miss vending machines over there very much.
They miss you
The
too.
best thing. Yeah.
Especially the liquor ones.
Oh, the liquor ones. Liquor ones are very good. Liquor ones are outstanding. All right. So we're going to apply the AC method here in this case. We're going to move the 3 over to the other side, so we added 3 to both sides here. Now we can apply the same steps that you see there on your previous notebook there. So first of all, I want you to go ahead and identify to me A, B, and C. So what's A, what's B, and what's C here?
Okay. A is 4x squared. B is 13x. No, wait. Yes. No, minus 13x.
All right, we're going to leave off the x's. Remember, I just want the numbers, the coefficients. That's all I'm looking for here.
Okay.
So be sure not to include the letters. We just want the numbers. That's what A, B, and C will represent.
Oh.
Remember,
Okay.
for a quadratic equation, that's ax squared plus bx plus c, okay? So just a friendly reminder here from a couple weeks back, okay?
C. Yeah, C is 3. Yeah, sorry.
C is 3. All right. Let's apply the AC method here. So tell me, what do we do first?
Okay. So, let me look. Okay, I'm cheating because I'm looking on my thing.
No, I want you to cheat. I want you to cheat. This is important. We're reviewing here, so it's okay to cheat. I don't have a problem with that.
Ooh, okay, let's see. So now I have to
Just
find the numbers to make A and C
what do we do before
multiply
that?
to add up to B.
Okay, that's the next step over. What was
Oh,
the step before that?
multiply A
Step one.
times C. No, before that.
Okay, so yeah, multiply A times C. That's right.
Okay.
So that's right. That was step 1. So that's going to be
12.
12.
Okay.
Okay. Now I'm going to agree with what you said here. That would be the next step there, step 2. So we need 2 numbers that multiply to 12, right?
Yes.
And what should it add to?
Minus 13.
Perfect. All right. Can you tell me 2 numbers that satisfy both of those requirements?
Add up to minus the. Wait, they have to multiply to 12 and add up to negative 13?
That's correct. Remember, 2 negatives make a positive.
Yes. Can they be point numbers? Can they be like partial numbers, or do they have to be whole numbers?
I mean, they can be partial numbers. That's fine, but that takes a lot more work to do if you're trying to do partial numbers.
Yeah.
These are actually whole numbers that you can actually get, integers. These 2, in this case, are integers. So we have different techniques to find partial numbers instead anyway. So
this would be 12. Oh, wait. Okay. No, hold on. Huh? To be. Okay. Nope.
Remember, we have. Oh, nope, not sure.
Nope.
Or you got it.
Nope.
Okay, that's okay. That's why we're reviewing this properly. Okay.
Yes.
So two numbers that work are 1 and 12. In this case, -1 and -12. That was my hint. Two negatives make a positive.
Yeah.
-1 times -12 is +12, and -1 plus -12 is a -13.
Oh yeah. Yep, that would do it.
Remember, you only have a few combinations here: 2 and 6, 3 and 4.
Yeah.
So there's only 3 possible combinations, and only one of them realistically adds to 13. You know that these two are gone because those will never equal 13 in some capacity.
So -1 plus -12 is -13. Or
That's right.
okay. I think I was confusing myself and adding it to 11.
Okay, okay. Okay.
Yeah.
I see. Like you were adding 12 and getting positive 11,
Yeah.
but they both need to be negative. Yeah. Okay. You know, again, I know that it's just going over the core basics there. It's kind of getting a little bit used to there, so that's fine. All right. Let me know when I should move on.
Okay, I'm ready for step 3.
Cool. Let's do step 3. What do I do next?
Okay. Now we rewrite the original problem by changing the bx portion using the two numbers found in step 2.
Perfect. Okay. So how should I rewrite that middle portion there?
Okay, let's
So
see.
we got the two numbers here,
That's,
-1 and -12.
so you do x squared minus x minus
Okay.
12x plus 3.
Perfect. Nice. You got it. So far, so bueno. Totally agree. And again, it doesn't matter which way you write the middle. Again, you could put -12x and -x. Doesn't matter
Yeah,
which way.
this part is okay. Yeah.
We just make the adjustment as necessary. So either way, you'll be fine. All right. Next.
Okay. Next part is step 4, factor by grouping.
Okay, so we're gonna group this guy. Okay. Remember, we're gonna bring that minus sign down here. Okay. So here we have 4x squared and x. What can we factor out of that?
X.
All right, sounds like a plan to me. What do we have left over when we factor out an x?
4x minus 1.
Got it. Nice. Very nice. Okay. How about this one here? We have 12x and 3. Factor
Okay.
out of that.
3.
All right, perfect. Now notice that since we brought down the negative here, we actually factored out a -3.
Oh,
Okay.
yeah, okay. Okay. Okay.
And what do we have left over after we took out a -3?
4x plus 1
Close.
minus
I
1.
agree with the -1 is correct, right? Because you took out a -3, so a negative of a negative is a positive. So that's why this sign will change. So both signs change because you took out a negative. So notice you get the same thing here. You have 4x minus 1. You get
Yes.
the same thing over here. You get the 4x minus 1. So that's how it should. If you're doing factor by grouping, that's how it should drop out. Is that you should have kind of the same term here after you factor both. So just a hint of predictability if you want to consider that.
Okay. Okay.
All right.
Yes.
Okay. Now let's do the last part here.
Okay. Now we have x minus 3 and 4x minus 1.
All right. Perfect. Sounds like a plan to me. Okay. And remember, at the end of the day, this is equal to 0. So let's not forget about that. We still need to solve for x in both of these cases. So what are we going to get for x in this problem here now that we've factored it out successfully?
0. So x has to be nope, that doesn't work.
Don't forget to set each one of the factors equal to 0 and solve for x.
So I do x minus 3 is 0, and 4x minus 1 is 0?
That's correct. That's the zero product property.
Okay, so...
So this takes away the guess and checking part. You just basically set each factor equal to
0. Now, 1 is going to be 3.
Agreed?
And then the other one... Seem to make that 3.
What about the other one? 4x minus 1 equals 0. Remember to add 1 on both sides first. So here you're going to get 4x equals 1.
Oh, wait, okay. Add the plus.
Divide.
This out. X is what? 1/4?
That's correct. 1/4. Nice. Or are you a little confused about that one?
Well, you have to cancel it out, I guess. So, but so now
Remember, okay.
what is my final?
Okay.
Oh, okay, yeah, okay, I got that.
You have your two answers are this. Now, are you a little confused about how we got 1/4, or are we?
No,
We
that I think makes sense.
okay. So I want you to understand one thing, Tony.
Yeah.
Okay, anything in algebra is always gonna. I probably mentioned it last time, but remember in your head, it's always gonna come down to one word. That's always a
Yeah.
balance. It's always balance. Algebra is going to be made easy if you understand that everything you're doing in these problems is just basically like a zero-sum game. You're balancing things out to manipulate it to get it to something that you can work with or solve for. You know, that's a lot of concepts are going to revolve around that idea of balance. Like you're solving for x, we're using techniques to get around to the point where we can actually, you know, we're employing that. So it's like, okay, we rewrite the problem to make it easier to manipulate. Okay. Again, just playing a zero-sum game at the end of the day. So
Okay.
we're just trying to do it as easy as possible, you know, without, you know, we may need to shuffle the deck, but it's still the same chairs at the end of the day.
That. What was
Uh,
that?
what?
That looked like something delicious.
Oh yeah, you know, I had to go to Mitsuwa, my local Japanese store, and I got myself some royal milk tea because of course I did. you think you think just because I left it didn't take no, man. You remember how much I would chug like royal milk tea in like 2-liter bottles way back when?
Oh yeah.
Yeah, that never left me. So that never left me. I love that Suntory crap, man. Like the best $3 you could ever spend for a 2-liter.
Oh yeah.
So no, it's freaking delicious. I love it. It's just expensive over here. That's all. That's the bad part.
Yeah.
Yeah,
Stupid.
I want my teas. I do miss that about Japan. There's not so much. It's just so many good drinks that you just can't get here. You know, you have entire aisles devoted to pop, but you don't have entire aisles devoted to amazing drinks like Royal.
Like the tears of the children.
Yes, and high fructose corn syrup.
Yes.
We all collect tears of the children and or our clients when they realize they just got ripped off. That's how I felt anyway.
The tears of the children.
Yep. All right. Any questions about that example?
No.
Nope. All right. Cool beans. All right. Let us do the next question then.
Okay, number 7.
Number 7. How do we solve quadratic equations by using the square root property? All right. So this one's going to be a little bit quicker than maybe this last question was. Still doing. We're going to just do an example. Most of these are just going to be like, hey, let's do examples and let's just figure it out. So, okay. So for this one here, it's pretty much just kind of an application kind of deal. So let's look at one here carefully and let's see how this works. I want to just do a simple one here. So you may have something that looks like this. Okay, x minus 3 squared is equal to 36. All right. And so normally what we could do is we can move the 36 to the other side, for example. We could square x minus 3 squared out. We could manipulate stuff around. But if you ever get into a situation like this, and this doesn't always apply to every single problem, but if you do get into a situation like this, then all you have to do is get rid of the squared. And the way you get rid of the squared here specifically is you take the square root of both sides. That's all we're going to do here is just take the square root of both sides just like so. That way the square root and the squared will effectively cancel each other out. And on the left-hand side, we're just left with x minus 3. On the right-hand side, however, is where things can be a little bit different. Okay, once you got the right-hand side all figured out, one of the toughest things about mathematics is that sometimes when you take the square root of something, when you first learn square roots, you say, okay, well, it's the square root of 4. And you say, okay, well, the square root of 4 is 2. And that's correct. Square root of 4 is 2. I say, well, okay, well, what's the square root of 16? And I say, well, the square root of 16 is 4. Square root of 4 is, what's square root of 16 is 4. All right, fine. But in these cases, we're not only taking just the positive answer that we normally get, we are going to take both answers here. In this instance, like the square root of 36 is plus or minus 6. So one of the things that I stress on here is that I'm going to be very specific at times, and I'm going to tell you where plus or minus is, in play. All right. So sometimes plus or minus is in play in certain topics, and sometimes it's not. Because of the context of the problem and what you're trying to find. Okay, so in this case, we are taking both the positive and negative answers here in this instance. So what that means is that, in fact, we have two equations that we need to solve for x for. So instead, we have x minus 3 is equal to positive 6. That's the first scenario. And x minus 3 is equal to negative 6. That's the second scenario. The work is exactly the same, but we will get two unique answers. All we have to do is add 3 to both sides. In both instances, we're going to get our answers for each. We get x is equal to 9, and here we get x is equal to minus 3. Negative 6 plus 3 is minus 3. And there we go. We got our two answers here for this particular problem. All right, good stuff. Let me know if you have any questions so far.
So if I understand, the reason why we have to use the plus minus is because if you multiply the positive values, you get the 36, and if you multiply the two negative values, you also get the 36.
That's correct.
Okay,
Yes.
cool.
Like I said, sometimes in certain concepts we don't even include the negative answer. Sometimes in certain concepts we do include the negative answer. So it's really weird how it works. Sometimes it's yes and sometimes it's no, and sometimes it's like, okay, why is that? Well, because of the context of what you're trying to find and where it fits in. So if it's just a generic one, we include both. All right, we're going to look at another one. Is that fine?
Yeah.
All right, let's do it. Okay, next one I'm going to do here is going to be slightly a bit tougher. Just it gives a full reminder about what we specifically need to look at here. So I'm going to do, which one do I want? That one. I want to do one that actually has. Okay. So this one here is a bit tougher, probably because it has a lot more moving parts to it. Okay. All right, so what we're going to do here specifically is we have 2x plus 8 quantity squared is equal to 27. Now what we want to do here first is get rid of that squared portion. Take the square root of both sides. Now this problem here I'm going to just kind of guide you through here because of certain things that you haven't seen in quite a long time. So I'm just going to show you really carefully about how I come up with some of the things that happen. So now the squared and the square root cancel out. And that leaves us with 2x plus 8 on the left-hand side. On the right-hand side, we end up with the square root of 27. Now the square root of 27 is, again, can be simplified down. The square root of 27 can be broken down into the square root of 9 times 3. And using the square root property, we can actually divide those two square roots, the square root of 9 and the square root of 3. Square root of 9 is 3, and we have the square root of 3, which we can't really do much with it. So we have plus or minus 3 square root of 3 on the right-hand side. That was using the, first of all, that was using the property of square roots there to simplify things down if it's possible. Again, it may not always be possible, but in this case it is. Questions about that so far?
No.
No? Okay. Hopefully that made a little bit of sense. I hope so. All right. Next, we're going to solve for x. All right, Tony, why don't you guide me through this? How am I
Okay.
going to solve for x in this instance? What should I do first?
Let's see. I'm going to put a 4. Mine. No, I
Put a
don't know what I'm gonna do. Hold on. Okay.
What's my first major roadblock? What's in my way here?
The plus or minus 3 times the square root of 3.
Okay. Let's go back. Okay. Let me shift gears here for just a second, okay?
Yes.
What we want at the end of the day, let's talk about our goal in all these algebraic problems, okay? Our goal is to get x is equal to something. You agree with that, right?
Yes.
Okay, good. This is important because then I'll show you why I'm constantly doing the same things over and over again. So x equals blah, 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 blah.
Oh, wait.
So,
Okay.
right.
So you're gonna make
So,
minus 2.
go ahead. Not quite.
No.
Not quite. Though that's a good thought. That's a good thought. Let's think about it. I want to get x by itself.
Yeah.
Because that's what we want. We want x is equal to blah, blah, blah. I don't care what blah, blah, blah is, but we're going to manipulate stuff as much as we can until we get x by itself. So the first roadblock that's in our way about the x is going to be the plus 8. This plus 8 is in the way. Okay, we don't want the plus 8 there.
Okay. So
Because, you know, we want to be able to isolate x, but right now the +8 is kind of standing in our way. So what's the opposite of +8 here?
All right, so the -8. So we put it on the other side.
Correct. Okay, that's exactly right. So what we have so far here is we have 2x equals -8 plus or minus 3 square root of 3. Okay?
Yes.
And now we can see the other roadblock in our way in trying to get x by itself. Well, what should I do next?
Take away 2.
Take away 2? We have 2 multiplied by x here. What's the
Divide by
opposite of
2?
multiply? That's right. Good. Got to do the opposite, right?
Yes.
So it's always the opposite. That's how we balance things out. We got to do the opposite here. So we're going to divide by 2 here. And so that'll cancel these two guys out. And that's going to be our answer here. You can split this up if you want. If you split this up, then you could just put these both over 2 and then simplify if you want. There's 2 ways to express this answer technically, which is why I'm going for this problem. Just to give you different looks about how you can express your answers. Just a different way to express your answers. You get the general idea about how it works. You can either look at it like this, or you can look at it like this. Both are equivalent. All right? And that's what we got here for x. Yes.
Okay.
Questions about that so far?
Okay. Do with 3 to the square root of 3. Do I do anything with that? Or is that just
No, you can't. Yeah, you can't do much with that. Once it's simplified down, that's as far as you can go with that.
what
So,
happens if it was
if
29?
like square root of 29, for example,
Yeah.
then you just leave it alone.
Oh.
Unless you could take the square root of one of the factors of 29, then make it a nice number, you leave it alone.
Okay.
I could do it in this case because 9 had a
And
nice number that I could take the square root of.
yeah.
But if I can't, well, I'm not going to make more work, right? And I don't think you do either.
Nope.
We're too lazy for that, okay? We're too old
Absolutely.
for this crap.
Yeah.
Yeah, okay. We're too old for this shit. Okay, then.
Danny Glover, I love you.
I know, I love it. I know. That movie's so classic. Movie's so classic. All right, we got one more to do here, and that's because it could pop up from time to time. So
Okay.
this one I'm gonna make super quick though. I don't want to make a super big deal out of it. All right. Let's say you had something like this: x minus 1 squared is equal to -1.
Okay.
Now you proceed to do the same thing here. That part is true. Okay, you take the square root. Now the problem is that the left-hand side works out just fine. Okay, that still cancels out. Everything's just the same like it was the previous two problems. The issue is what happens on the right-hand side. In reality, you can't take the square root of a negative number. That's
Yes.
not possible. All right, but we do have a designation for the square root of a negative number. In this case, the square root of -1 is designated as I.
It's an imaginary number.
It's right. Remember that? Yes. Yes. So sexy. All right. All right. Absolutely. So, yeah. So I is equal to the square root of -1. So I squared, you could look at it, I squared is equal to -1. I third, I'm not going to expand on that. But this would be plus or minus I here. because that's, again, you take the square root, so plus or minus is still in play. You get plus or minus I. And at the end of the day, that's all you got to do is you just add 1 to both sides. Again, just like a regular algebra problem. And you get x is equal to 1 plus or minus I. Okay? So I wanted to show that off really quickly because imaginary numbers could pop up here in different concepts here. Don't be surprised where it comes from. Again, um, again, we don't want another Randy Orton moment. So with our brains, that'd be pretty bad. So yeah, there we go. Good beans. Questions?
No, I'm just gonna
Cool.
imagine a whole bunch of stuff.
I know what you're imagining right now, and I like it.
Oh yeah.
uh,
No, it's a
too
Super
easy.
Bowl win. It's a Super Bowl win.
Yeah, that's right. A Super Bowl win this Sunday.
That's right.
Tom's gonna run. Tom's gonna have like. Tom's already run out of fingers about how many championship rings he's got. How many trophies he has in his collection. How many MVP trophies he's won. I don't know. When it came to him going from the AFC to the NFC, he outdid Aaron Rodgers. So it's like the best quarterback in the NFC and just absolutely destroyed him. So
Oh yeah.
can't there's no comparison now. Everybody thinks Rodgers is better than Brady. Yes, Rodgers was the MVP this year, no question about it. But then, it took Brady a little bit of time, just a few games to get more comfortable into a new offense in a new city. But once he did, he just rolled over everybody like he always does.
Oh yeah.
Oh yeah. I bet Belichick's eating crow right now as we speak. So it's like I could have been back in the Super Bowl. And like you had Cam Newton, that was your problem.
Ooh.
So
Yeah. Ooh. Imagine the
oof.
quarterback behind him though. It's like I'm worse than this guy.
But they have Jason Statham, right? Jason Statham, a guy who hasn't taken a snap in like 2.5, 3 years. Jason Statham. Oh my gosh! It's like you guys got rid of Jimmy G for this. Really, guys? You could have at least had Jimmy G.
Well, Jimmy G is a glass cannon.
Yeah, he is. He is a glass cannon, but he's a more serviceable quarterback than Jason Statham.
Yep,
Jeez.
it's true.
Oh my gosh. And it's just I watched him play those few snaps, just looked absolutely abysmal out there. Like, oh my gosh. Wow.
We gotta sign Mark Wahlberg.
You know what? You know what the Patriots gonna do? There's a lot of great quarterbacks out there, but I bet they're just gonna go. They're gonna go the Sam Darnold route. I could just totally see that. It's like you're comfortable.
Sorry.
I know. I know he's bad. I know he's bad.
I think I
I
think
know.
I'd rather see Cam back there. At least I know why he sucks. Like
Right? Exactly.
yeah, like he just can't throw the ball. That's fine. Like I know
Yeah.
that. I get that part. Okay, he can't throw it. It's cool. But
Hmm.
Sam Darnold has no excuse. He can throw the ball. He just sucks.
He can. He does. He just sucks. That's true. Though he was playing on the Jets. Let's be honest
No,
here. It's the Jets. It's the Jets. It's
no.
the Jets. Okay, the Jets are bad. The Jets have been bad since like 2005. Okay, the Jets are bad.
Yeah,
Okay.
yeah.
The
But
J-
the Dolphins have been bad for a long time too. But they
yeah,
had a
but
quarterback who could throw, and then they were good.
they had a
But Sam
quarterback.
Darnold could
What?
throw,
They
and
had
the
a
Jets
quarterback.
still suck.
Yeah, that's true.
That
That's
must
true.
be Sam Darnold's fault.
Are you sure it's not Todd Bowles or Adam Gase?
Adam Gase sucks too.
Adam Gase was terrible. So I'm limiting my blame on Darnold on a lot on Adam Gase because Adam Gase couldn't coach worth a darn. Like there's no way There's no way Adam Gase knew what he was doing. There's just no way. Let's see. I'm looking at the. Hang on a second. Okay, take a look at this list. Right. Look at this list of free agent quarterbacks. All right. So you have Dak at number one, but nobody knows how Dak will be after his injury, and that was pretty devastating. Um, yeah, Mitchell Trubisky, which I'll be honest with you, it is
No,
is
they had
it's
all the
a little.
pieces in Chicago,
Yes, they
and
did.
Nick Foles, motherfucker, fucking Nick
Well,
Foles, Nick Foles,
you need to get over that, okay? Look, Brady's got a lot of rings, okay?
fucking Nick
He's represented.
Foles.
All right, if Brady was salty about anything, it's the Eli Manning New York Giants win in the Super Bowl with David Tyree. I don't know how many times I trolled you about that when I was looking over there. I know that he's still salty about it to this day.
Sometimes I wake up screaming about Tyree.
It's like the one hit wonder, but that one hit absolutely devastated a perfect team. It's just the most
Well,
craziest thing that
then the
happened.
most egregious face mask penalty in the history of the universe. Right after that,
That's true. That's very true. Well, it's not as bad as the pass interference in the NFC
oh yeah, that was
championship
pretty
game last.
horrible.
That was pretty. It's like the ref standing right there. I'm like, he's not even looking at the ball, and he's like, guy's jersey in both of his hands. Like, how do you not call this? I'm like, there's not even a need of a replay. Just take out a flag and just throw it on the ground. It's so bad.
Yeah, definitely missed that one.
Yeah, it's like deer in headlights. It's like, guys, there's it's so clear.
Why? I'd like to just ask about the number 8 quarterback on the top available NFL free agent quarterbacks in 2021 list.
what would you
What is
like?
he
What would you
even
like to
doing
say?
there?
Because okay, look what it says. Somewhat underwhelming group of free agent quarterbacks. It isn't wrong. Most of this team is pretty underwhelming. Look, Tyrod Taylor got stabbed by a syringe and got a collapsed lung because of it, which was really unfortunate. But Justin Herbert was I think he's a pretty good young godsend for the Chargers, even though they weren't that great this year, but still very very good talent. Jacoby Brissett, I don't know what Indianapolis is going to do now that Philip Rivers retired. So I have no idea what's going to happen there. Fitzmagic looked better than Tua pretty much most of that season. For whatever reason,
I think that's because
they had a
Tua is
quarterback.
5 feet tall.
Yeah, look, they had a quarterback controversy. I'm like, why? Fitzpatrick's throwing out of his mind. He's a streaky quarterback. He's gonna throw a lot of picks. He's gonna throw a lot of touchdowns, but he's really good. He's just you can't stop him. And he was doing really well, and they're like, no, we'll just go to Tua. I'm like, why? Why would you do that? Why would you jeopardize your season? I mean, they almost made the playoffs because of that fact. And they would have if they didn't go to Tua like halfway through the season, where they had a identity crisis with your QB identity crisis. Essentially, is what you had. And you had a famous Jameis who was like, eh.
That guy,
Mitch,
he
you know,
could, well, he benefited from Godwin and Mike Evans because those
yeah,
guys just run and catch the ball. And he
it's
was
true.
just like, let me just throw it up there and they'll go get it. And I'm going to throw for 6,000 yards and 5,000 picks.
It's true. Look, Mike Evans is ridiculously good.
Yeah.
Ridiculous. He's been good for a long time, regardless of what quarterback you put in there. Like he's always been a pretty solid wide receiver. So no question about that. I don't know how Tyrod's gonna go over now that he's a year out of just really throwing any passes.
He'll be all
Andy
right.
Dalton's Andy Dalton's a Andy Dalton's an interesting story. I don't know what to make of Andy Dalton. He looked good for the Cowboys for the time he was in that backup role after Dak got hurt. So maybe just needed to change his scenery away from Cincinnati. You know?
Well, Cincinnati and Cleveland are where good players go to die.
I don't know. I thought Cleveland did pretty good. I mean, they won a game in the playoffs. How can you argue with that?
Uh, the Titans won a game in the playoffs too, and they suck.
Cleveland Cleveland got their due this year. I think Baker Mayfield saved his job. So I think
True.
that I think they have no defense. I think the Browns have like absolutely no defense at whatsoever which to speak of. I believe you could run for like 500 yards and throw for 1,000 yards a game against any Cleveland Browns defense that you're going to throw at them. But I think that they do have a good offense. Do have a legit offense. Man, Allen Robinson, I feel bad for Allen Robinson. I really do.
Yeah, he's good.
He's good, and he didn't get paid, but
Chris
our
Godwin's a
management's
free agent. Oh no!
man, they're gonna have to give him money. Though actually, there's gonna be a big problem this year because of the lowering of the salary cap. So you saw those numbers, right, for the salary cap?
No.
Oh, okay. Let me show this to you, buddy. I gotta show you this. Salary cap is really low next year because of COVID, right? So if we go, let's go to the Bucks, right?
Oh, they're fucked.
Brady's cap hit is 27.8 million.
Tasty.
Worth it, but it's a very large portion of. But again, I'm gonna scroll down here for just a second, and that is, fortunately for the Bucks, they've spent well. Their cap space is 38 million, so they can go out and they can they're probably going to give Godwin a new deal with the 38 million, right?
Yeah.
They're going to probably give Godwin a new deal. I would give Godwin a new deal. Heck, I would go and sign Allen Robinson for like 16, 17 million with that money. Like, I'm not even joking. I would sign Robinson. They would make it even more deadly.
They should. That would be incredible.
That would be incredible, and I would root for the Bucks all year if they did that. Like, no, I'm not even joking. It's crazy. Let me show you the craziest one. Let me show you the craziest one.
Wait,
I want you to
wait.
take a look.
Tampa Bay
yes,
gets the AFC East next year, right?
I believe so. I believe so. I think they do actually.
That ain't right.
Oh my gosh. I gotta show you this though, buddy. I gotta show you this. Look at New Orleans. Look at how far over the cap that they are for next year. Look at that.
Shit.
Look at that. Look at that number that they have to cut. Look at that number is so bad. Nearly $100 million over the cap for next year. I don't even know how you trim that much payroll.
Goodbye, Kamara.
Yeah, goodbye, Drew. Goodbye, Kamara. Well, who can you cut here? I mean, look at these dead cap. Look at these cap hits. I mean, if Drew retires, they take a cap hit of 22 million. So that's like 14 million off the board. If Michael Thomas leaves, they take 5 million extra in dead cap space. Like, I don't know how you even manage this payroll. This payroll is outrageous. Absolutely outrageous. I don't even know. Yeah, you gotta like cut like at least half the team to even start getting underneath the cap. Just
Talking about selling out for a championship.
Yep, and you didn't even make it to the championship game. Sucks to be you. you only beat the Bears, and that's not saying much this season. You only beat the Bears. Sucks to be you. Oh my gosh.
With the Bills are in a good spot, jerks.
Yeah, you got to give it up to the Bills this year. Bills did really good this year. I'm proud of the Bills. I'm proud of seeing the Bills being not completely destroyed by the Patriots every year. So
Brady left. They just have to wait till next year so that Brady can ruin them again.
At least it'll be for one game and not twice a year where they just like get destroyed.
That's true. That's true. It's only one game,
that
but it's gonna bring
that
back PTSD for everyone in the greater Buffalo area.
That's true.
Or
I
what is
do
it?
like Josh.
PTSS now? Is that what they call it?
Yeah, yeah, yeah. I do like Josh Allen though. Josh Allen is a amazing quarterback. He really grew this season.
Oh yeah, no, he's good. Brady's just gonna ruin him for all time.
Nah, I think Brady just ruins every other quarterback. I think that's just kind of like de facto. That's a de facto thing. Like when Brady, Brady will retire when he's like 50, and he'll just ruin every quarterback that comes into the league, regardless.
Next
Because
year,
that's just who Brady
you heard it
is.
here first. Brady's gonna throw for 97 touchdowns.
Wow, 97.
Yep.
That's a very nice arbitrary number you came up with.
You like that?
Where's I do. How many picks?
30.
Oh, I thought you would say -5. Then I would be like, yeah.
He's gonna get some back.
That's right.
No, he'll
You'd
have
be
to
like,
throw it about 4,000 times,
yeah, that's right.
and it's gonna be amazing. He's gonna have
Yes.
17,000 yards.
So here's the scenario I'm thinking is that Brady's gonna throw a pass. It's gonna be picked off. It's gonna be a forced fumble, and then Brady just gets it back. So it's a negative interception at the end of the day, and everybody wins.
Yeah,
So yeah, see, every single one.
and it'll still be a first down.
That's right. That's right. Automatic first down. The golden boy.
I like it.
love the golden boy.
No, wait. I want to see him throw a pass on the 1 yard line. It
Okay.
be intercepted, then it
All right.
have be a fumble and recovered in the end zone for the touchdown.
Oh, yeah, there you go.
So that's what I think should
like
happen.
that. That's what I think should happen.
I want to see it
Or
in the Super Bowl too.
how about this scenario? Brady's backed up at his 1. He fumbles in the end zone, right?
Yeah.
And then everybody's scrambling around for the ball. Brady picks it up, runs for 100 yards for the touchdown. He'd be like the slowest man on the field. He'd look like he'd have the he'd have a defensive lineman trying to catch up to him, and he'd outrun them all for the touchdown.
Somebody needs to make that deep fake video.
You try and put
be
in
honest,
slow
I'm
mo.
not even sure Brady could do that.
Yeah, he's put in slow motion. He's going like this. He's like.
Somebody gives him oxygen from the sideline.
The offensive tackle just comes in with a tank rolling behind. Take this, bro. Take this. He's like pumping at the same time.
Oh man, I like it.
Oh my gosh. Oh, that's hilarious. Oh, I love you, Tom Brady. You're amazing. All right. All right. You ready to do you ready to do the next one? Ready to do the next one, my friend? All right. I know you've seen this before. Ready? All right. How do we solve quadratic equations by the quadratic formula? I think you remember the quadratic formula. At
Quadratic
least I hope you do.
formula. Okay, hold on.
Okay. Anyway, in any case, let's refresh your mind on the quadratic formula.
Okay.
All
A
right.
squared plus B squared. No, wait. Where is it?
Yeah, and that's Pythagorean theorem.
Oh.
So this one was the negative b plus or minus square root of b squared minus 4ac all over 2a. That's the quadratic formula. This basically is like your last resort. right? So if you can't like factor it using like the AC method, or if you can't factor it, or you can't solve for x using the square root method or anything like that, and the numbers are really awkward to use, you can use the quadratic formula to essentially solve for x in both of those cases.
Okay,
So
I'm gonna write this down because I don't have that in my notebook.
that's fine. That's exactly the point.
I'm gonna be honest. I don't like the quadratic formula. It looks pretty ugly.
Um, okay, so I want you to look at my face on camera and
Okay,
look at the quadratic formula. Tell me which one looks nicer.
your face.
The answer was neither. Thank you. All right. So
Wait, wait, wait. So I got that wrong too.
Yep, you did. Both were just equally as ugly.
Okay, I'm noting. Use as a last resort.
Yes, use as a last resort if you can't factor. So I guess I'll add that in as so if not nice factoring. All right. So let's do a problem here with the quadratic formula. This won't take too long to do. It's just plugging and chugging in numbers. So
Plug it and chug it. That sounds
yeah,
like
baby.
a frat boy's dream.
Yes, and I know you know more than I do on that matter, so we're gonna just leave it at that. We're gonna leave it at that. Yes, sir. I haven't forgotten the stories you told me, Tony. I
Oh,
haven't forgotten them.
oh, good. That's good news. That's bad news.
It is bad news. The fact that I still remember what you told me, way back when, should give you pause.
So the quadratic formula. Yes.
This segment of the show is brought to you by Last Time in Bandcamp. Last Time in Bandcamp. Last Time in Bandcamp. I think we all know where the stick went. Last
Oh,
Time in Bandcamp.
oh, we
Uh,
do now.
on at 8/7 Central. All right. All right. Let's go over A, B, and C here. So if we don't know what this factors to, this doesn't factor in nicely, by the way. This looks like it kind of does, but there's not two numbers that multiply to 3 and add up to 5. Okay, so that's kind of one way you can try and do the AC method here,
Yeah.
but you'll quickly realize that, oh, it's not going to work out. Okay. So let's identify A, B, and C here. So walk me through this here, buddy.
A is
Hey, what's A? What?
1.
Perfect. Keep going.
B is 5.
Nice.
And C is 3.
Nice. All right. So we're going to plug this into the quadratic formula. Now remember, one of the things that I talked about before is that anytime we substitute, we're going to go ahead and put parentheses around that number there.
Yes.
So we're going to go ahead and put -1 with that. Just in case, again, like I said, I know it's asinine here, but again, a lot of times signs could easily change. So we want to keep that in mind because signs are a pain in the butt.
Wait,
So
should that B be 5?
what did I put? Oh, I put 1. Oh yeah. See,
Oh.
you're
Whoop. Okay.
See, you corrected my mistake. See, who's the idiot now? The
Definitely
guy
me.
who roots for the Bears. That's who.
No, that's an unfortunate byproduct of where you were situated.
I mean, I did watch the Bears win the Super Bowl back in '85, and that's the only thing anybody else talks about
But
is
you
the
got the
last time we
Super
won the
Bowl
Super Bowl,
shuffle.
which is
No
now
other,
like 35 years old.
no other team has that. Or
And
will
yet,
again.
and how many
Thankfully-
how many championships did the Patriots win in the past 20 years? I think
Oh,
I'd rather take that.
yeah. I think a lot of people would rather take that.
Yeah. Look, it's like we got spoiled with the Bulls winning 6 championships in 8 years. We got spoiled with the Blackhawks winning 3 championships in 5 years. 3 Stanley Cups. We got spoiled with the Cubs winning in 2016 and the Sox winning in like 2005. But the Bears have always played second fiddle to Green Bay, and I've always looked for a quarterback every single year since yesteryear. So yeah, it's a perpetual motion machine that never stops. That's being a Bears fan.
I
That's the
get that.
reality of the situation. It's the reality of the situation that our management is, has our management sucks. So, all right, let's go ahead and figure this out here. Got 25, and we got minus 12, 4 times 1 times 3, all over 2. So if we quickly do this out here, we're going to have negative 5 plus or minus the square root of 13, all over 2. And these are going to be our 2 answers for this problem here. We can't really do anything beyond that. And that's our final answer for this problem,
Oh,
at least for this problem. hmm
got it.
Now, again, you could have remember as we talked about before, you could have a negative square root in here.
Yeah.
So if you have like the square root of negative 12, again, that's going to be the I, you can bring out I here for the square root of negative 1 times 12. And then you can simplify square root of 12, which is going to be 2 square root of 3. So this is what it'll look like so. And 12 is 4 times 3. So that's how I got 2 root 3 there. Just to give a little bit of a heads up there about where I found that out. Okay.
Yes.
All right, cool. All right. Questions about that one. Quadratic formula is really straightforward. You just have to just don't forget to move everything over to one side. Okay, so make sure it's equal to 0. If it's kind of mixed around there, just make sure everything is on one side of the equation, and then start working with A, B, and C. Okay.
Yeah.
All right. Cool. All right. Now I do want to get talking about functions here, so I'm gonna quickly go over. Do I want to do this last one here right now? Should we kind of do? There are questions on the MyMathLab stuff, but I want to get into the meat and potatoes. Fortunately for us, we can be pretty loosey goosey about what we do. So
Yeah. Plus, I got
it.
like it's going to be
You,
at least 9 weeks before I even start the class. So
okay, cool. So what I'm going to do here is I'm going to kind of skip number 9 here for now. We are going to probably, if there is another concept regarding number 9, we may see that later
okay.
about how to do that. So I'll talk about the steps then. Um, just don't worry about doing the homework problems relating to that. If it says completing the square, just kind of skip it and move past it. We're not, we're just doing this kind of casually. So um, it's fine if we can skip around a little bit because I want to get to the more heart of the matter here, if you know what I mean.
Yep.
All right, cool. All right, so let's move forward here. I'm gonna move into chapter 2 stuff. All right. Okay. Let's talk about things here which are now something that you've been wanting to ask for a while. What is a function? What does it do? Who is your daddy and what does he do? Something like that. Everybody knows that. All right, so I had to do kindergarten cop at some point in the stream. That was important. All right.
Incredible movie.
Incredible indeed. I love that flashback scene where you see his dad just come out of nowhere in like a conveyor belt through the window. He's like, "No!" Oh my gosh. I still remember that. All right. Anyway. Okay. So let's talk about number one. Number one is, what is a function? Okay. So the way a function works is that you have two sides for a two-dimensional function, okay? You have two sides for a two-dimensional function. If you have a three-dimensional function, on the other hand, you're going to have, say, xyz, for example. You'll have a three dimensions if you're working with a 3D model, like if you're doing computer programming, right?
Yeah.
And you have a 3D model, it'll be an XYZ format, XYZ. For our purposes, we're working with just a 2D model. So if we just have X and Y respectively. Okay, so we're going to have one side here, we're going to call it X, okay? And X is going to contain some stuff. And we'll have another box here, we'll call it Y, and that will contain some stuff in there. Okay. Now imagine, if you will, we had, say, 1 and 2 in the X, and we had 3 and 4 in the Y. Okay. Now I can draw some arrows here, and I could tell you, yes, this is a function, or no, this is not a function. So if I draw an arrow from 1 to 3 and I draw an arrow from 2 to 4, I can tell you that yes, this is indeed a function. Okay? All right, I can tell you unequivocally this is definitely a function. I'm going to modify this picture here just for a few examples here really quick. Okay, Tony? So I'm going to get rid of these two arrows. But if I redraw the picture here, if I say, okay, well, if 1 goes to, let's say 1 goes to 4 here, okay? So if 1 goes to 4 here, I'll still make the contention that, yes, this is still a function. That's perfectly fine. This is still a function. Even though 2 doesn't go anywhere, that's okay. We have one number going to another. Cool. I'll make this contention as well. I say, okay, well, let's say 1 goes to 3 and 2 goes to 3. Let's say that happens. That's just another scenario. I'm going to make the contention here that, yes, this also is a function, okay? This 2 does work, okay? As a function, all right? No problem. This is, yes, a function. Now let's go to the last one. Let's go to this last scenario here. Let's say I have 1 goes to 3, but I have 2 goes to 3 and 2 goes to 4. In this instance, this is no. This is not a function. Now let's talk about why that is. Why is that not a function? Compared to everything else, you're like saying, hold up a second. Why is this scenario not a function, but the others were? Well, the reason is because of the definition of a function here. So a function here specifically is a relation in which one x value goes to exactly one y value. Technically, they can all go to the same y value, but it has to be a 1 for 1. Okay, so I can't have one x value go to two different y values. That's not possible. One x value has to go to exactly one y value. So as you see there in the picture, that cannot happen where I can have one x value go to two separate y values. Not a winner, unfortunately. Now, one of the other things in relation to functions here is notation. So what's the notation here for functions that we're going to use? The notation here specifically is going to be f of x. Okay, now you can use any letters that you want here. Sometimes you'll see g of x, sometimes you'll see h of x, p of x, okay, s of x. You can look at any one of those letters. You don't even have to put x as long as it's put in that terms that letter. So you could have like s of y, g of t. Okay, those are pretty common for like physics types of problems or whatever.
How about S
So
of M?
yes, that too. Hmm. Does M like being dominated?
It does. That's why it's inside the brackets, inside the
Oh my
parentheses.
goodness! God. Oh my gosh. Now I'm now I'm gonna make I'm gonna make a note about this here. All right. So to make sense of this here, one thing that I do want to point out here is f of x is the same thing as y. Okay. So I want to make a note about that here. F of x is the same thing as y. This is actually pretty important here. Okay. F of x is the same thing as y. All right. There is no difference in that regard. We're going to actually, in a lot of in a lot of ways, we're going to actually exploit that note here a lot when we actually look at, say, graphs and whatnot. So when we look at those, we also want to kind of think of it in that perspective. It's like, oh, I'm looking at actually at y when I talk about f of x. So you'll see this note pop up quite a bit, and we'll be using it kind of repetitively here when we apply it.
Okay.
Okay. Now let's talk about the next part here. How do we evaluate functions? All right. So let's talk about how do we evaluate functions here. Let's go ahead and plop down some guys. All right. So let's put in f of x here is equal to, let's go with 2x squared minus 5x plus 7. Okay, so just making some stuff up here. Okay, there you go. So what we're going to do here is let's just pick some random numbers, okay? Let's say I had f of 2. Okay, so just f of 2, all right, just like so. So what does f of 2 represent? Well, f of 2 is going to be the y value when we plug in 2 in for x, okay? That's essentially what we're going to be doing here. What if we plug in 2 into this function here, we're trying to find its respective y value that would go with, okay? So all we want to do is, of course, plug in positive 2 here for every x in f of x. So as I mentioned here before, remember as I said, we put parentheses around whatever we substitute. Well, this is one of the big reasons why, is because if we're going to be working with functions, quite often, well, then we want to see where we're plugging in our numbers here specifically into our function. We know exactly where they need to go. It'll look something akin to this. Connor, hey Connor. Thanks, Connor. Okay, so I want you to take a look here. We have 2 squared, right, which is 4, times 2, which is 8, minus 10, plus 7. So if we put this together here, we're going to get, good morning, I think it is this stage. How am I? Yeah, I'm doing good, Connor. I know it's super early in the morning for you. We're going to get 5 here as our final answer here. Yeah, that's right. Nice. So does that make sense there?
Yes.
Any questions about that?
No.
All right. No. Okay, let's try another one. All right. Let's try minus 4. Okay. So why don't you go ahead and try this one out? Tell me what you would get for minus 4.
Okay. $59.
59. Let's check it out. Sounds right to me. Check it out anyway. Oh, that should be minus 5, not minus 4. All right, so here we get 16 times 2, 32. Minus 5 times minus 4 is going to be positive 20. Plus 7. So 59 is correct. Yes. Nice. stuff. Let's try another one, because sometimes you may need to do things a little bit more abstract. What do I mean by that? What happens if we have this? What about f of minus x? What's that going to be?
-1.
Not exactly. Take a look at what I did here. Remember I mentioned here that if you plug in anything in there, you put parentheses around what you substitute, right? You would agree with that?
Yes.
Okay. Now take a look what I did for numbers, right? Wherever I put in a 2, I put that in place of an x. Okay, wherever I put in where I had f of -4, I went ahead and placed -4 in for x. So when I see f of minus x, I'm not going to treat it any different. I'm going to have minus x in those places in for every x in f of x. See what I did there?
Yes.
I don't want you to get confused here and say it changes, everything's different. Like, no, the actual approach is exactly the same. I can't tell you how many people get confused by this. Like you have to do something special because there's letters instead of numbers. My contention is that no, you're not doing anything different at all whatsoever. You're doing the same exact thing as you did before. There is absolutely no difference. Absolutely none. You're now just plugging in minus x in place of x. Okay, that's fair. It's abstract, yes, but it's fair, yes. So here, we're going to get positive 2x squared plus 5x plus 7. Yeah, so we just want to, Connor, we're just going to figure out what it would be if we just plugged in minus x there. Jade, remembers this learning this in school? All right, yay. Nice, nice. Questions about that so far? We're gonna do one more here for sure. Let me know if you have any questions though.
Do we do anything with the 2x squared? Do we factor out the x?
Nope, that's it. That's all you have to do.
Oh, okay.
Yeah, I know. You're thinking, do you have to do more than that? Like, no, actually, you don't. Sounds like you do, but in reality, you don't. Because it's just evaluating, so you're just plugging stuff in and chugging it out. All right. There. Okay. Let's do one more here. What would you do for this? What would you, x minus 2? X minus 2. What do you think we should do for this?
Okay, let's see. So, first,
This one's going to be a challenge, so don't get too frustrated. I'll guide you through some of the parts there, okay?
I'm going to put x minus 2 minus 2, then I'm going to go 2x minus 4, then I'm going to multiply that by 2, I'm going to go 4x minus 8, 5x plus 10 plus 7. 4x squared. Must be. So I am going to get 4x squared, 5x plus 9. Okay, I'm going to come up with 4x squared minus 5x plus 9.
All right, let's take a look. All right, so we're going to have 2 times x minus 2 squared minus 5 times x minus 2. And then the plus 7 is still on the outside here. That didn't change. All right. So what we're going to do first is we're going to expand x minus 2 squared. So this is probably one of those parts here that either probably will make or break your answer for this problem here. So let's see if it worked out for you. Hopefully it did. So x minus 2 squared is x minus 2 times x minus 2, right? So we're going to basically FOIL this out here.
That should have been 4.
We're gonna...
Should have been plus 4. Okay.
That's why we're going over this carefully, one step at a time. We do x times x. Hey, Doritos Alex, how are you, my dude?
25.
So we get x squared. We get x times minus 2. That's minus 2x. Get minus 2 times x here. That's another minus 2x.
Oh, fuck.
We get minus 2 times minus 2 is plus 4. Yeah, I figured you missed the middle term there, right? Yep. This is exactly why I'm going over this problem here. Making sure we get rid of those bad habits of forgetting the middle term. No worries, though. You're fine. I did that shit on purpose. I'm sorry.
Okay.
I did that shit on purpose because of the fact I just want to see exactly kind of what the aptitude is. So I just need to go over those like little points that I can. So trust me, I'm not here to make you feel bad. I'm just be like, oh, we need to kind of go over this part and this part and this part. But does that make sense about how I did x minus 2 squared?
Yes. So this is incorrect. And this is
Yeah, just
incorrect.
just ask me whatever questions there, Tony, okay? Ask me whatever questions there.
Yeah, okay. So I got it. So okay. Minus 2x minus 2x. Okay.
Yes.
Plus 4. So that then becomes plus. Now all of that is multiplied by 2. Okay.
Yes, that's why I put I put that result there because that's x minus 2 squared, and then I put the 2 on the outside from the beginning of the problem after doing the substitution. Right. So then I'll distribute the 2 here to each term. So I'll have 2x squared. 2 times minus 4x is minus 8x. And 2 times 4 is 8. I'm also going to do the same thing here with the minus 5. I'm going to distribute that too. Minus 5 times x is minus 5x. Minus 5 times minus 2, so a negative times a negative is a positive. I'm going to have plus 10 here. And we do plus 7.
And 2x squared minus 13x plus 15? No.
Almost.
17 plus 8, 25.
25, yeah.
Okay.
And that's your answer for the problem.
Yes.
Okay, so let's recap. Let's recap this example here. Number 1, the substitution is exactly the same as the previous problems. Okay, just putting in wherever we see x.
Yeah.
In f of x. Okay. Number two, remember to foil things out. And if you need to foil things out, I think let me ask you this question here, Tony. You feel more comfortable in a kind of a visual representation, correct?
Yeah, like what you did there is
Okay.
perfect for me.
Yeah, yeah. Okay, good. So I want you to continue to do that from now on. Is that if you have to square something or something like that, just write it out so you can physically see it.
Yeah.
I can do it in my head, but that's because I had a lot of practice. And some people can do it, but I don't recommend it for everybody. I always ask, hey, do you like things, like to see it visually? And if you say, yeah, I work better that way, then I'd be like, yeah, just keep rolling with that because it's just a lot easier just writing it out and then seeing it with your own two eyes.
Yes.
So yeah, yeah. So like if I wrote x minus 2 squared, you could write 3x minus 7 squared, and then you can write that out to see what it would work out to be. And I highly suggest you continue to do that regardless of whatever topic uses it. So I just want to establish that to hopefully give you good habits that will be more conducive to how you learn.
Yeah. No, it's great.
Yeah.
Thank you.
Okay, cool. Cool, cool. Um okay. And that in a sense is our final that's basically our final answer is going to be pretty much pretty much that. I just wanted to give you different looks about how to look at it from a strictly from a numerical perspective or a more abstract perspective because you encounter both when you're doing college algebra.
Mm.
That's just natural. So no matter what, that's how it's going to be. Even if you're doing computer science, remember when you're building a function, you're not building a function using necessarily numbers. You're building it from an abstract perspective and then plugging in values and then putting it through a loop, something to that effect. So remember that's how it always works, right? You want to be able to apply it to a more general case, right? So if you're coming with the function in a in a computer science in a program, you want a generic, you want it from a generic point of view,
Yes.
and then be able to apply the values in that generic point of view to whatever extent you want to manipulate it to. So my computer science experience, Tony, is limited, but I still remember what I did in C++ way back when.
Oh
So
yeah.
I know I have a bachelor's degree in it, and I have never used it like ever. So,
Well, you should use it now. Create a math web page.
oh my gosh, no, I don't even want to think back to those days. Those are back to the super old days when you're still using Netscrapes, and Google was around, but it wasn't as popular as it is today. So, I mean, this was like at the end of the age of Alta Vista,
Oh,
and then
Alta
kind of working
Vista.
way up.
Oh yeah.
Yeah. GoDaddy, GoDaddy, yeah. Geo, Geo, Geo.
Oh man, I wish I had seen your MySpace page.
I never did MySpace. You'd be surprised. I never did MySpace. I never touched that stuff. Net, net, Nets. I did Netscape, Alta Vista, GoDaddy, GeoCities. Google was around, but again, not as popular
GoDaddy
until it
might be
blew up.
even better than MySpace.
Yeah, that's kind of true. That's kind of true. Oh man, all super old school. Those are the things back then, man. That's how you found everything.
Alright, give me 1 second.
Er,
I'll be right back.
No problem, dude. Eh, What a chill stream tonight. Yeah.
Okay, I've returned.
All right, no problem. Okay. All right. We got a small break in there. That's good. All right. So that's that there. Good stuff. All right. So that's evaluating functions there. We'll there's so many times you evaluate functions, we're gonna see it like repetitively anyway. So ain't gonna be that big of a deal. Where are we gonna stop here? Yeah.
Can we save that next section over for next week so that I can
Are,
sort of keep building little by little?
are you talking like 2.2, or do you want like stop? I was considering stopping at question 6 and then moving to question 7 as a friendly reminder from last week, and
Okay.
then moving into question 2.2. Yeah, 2.2 is like its own kind of beast. So I definitely am not going to do like that section. I didn't plan on doing that.
Yeah. No, no. If
It,
if we can actually like this part, this is good. For me for today, I have some coding stuff that I need to work on as
oh,
well.
you want to you want to stop here for today?
Yeah, because
Okay.
that
Okay.
review from before gave me a lot of good
Mhm.
information. And if we
All right.
can do, yeah, like for me, I wanted like you wanted this is slow for you, but for me, I need to go slightly like I need
Yeah,
that bit of review, then plus
that's
one or
fine.
two additional topics, and then sort of continuing.
Okay.
Like this is
T-
good.
t-
This is really good
yeah,
stuff for me.
Tony, you dictate the pace to me.
Okay.
So I'm not the guy who's going to tell you we got to push through all the time. If remember, we're doing this as a way to kind of get you prepped for a 9-week course.
Yeah.
We might not get through everything what the 9-week course will cover necessarily. Okay, so there's going to be things you may have to learn faster just because of that fact.
Yeah. No, that's
But
okay. If
if
so, I'm gonna ask you about it.
but that's right. That's right. You're gonna ask me about it anyway. But you're right. I want you to go at a comfortable pace where you're not going to feel overwhelmed, where it's not going to be like it's a complete slap in the face if I go a million miles an hour. That's not what we're doing this for. We're doing this for you. It's not for me. So I want to be sure that you're comfortable. And if you say, hey, this is where we need to stop, that's fine. My intention was to stop at question 6, but if you say, hey, this is enough for me,
Yeah.
I'm fine with that too.
Yeah.
I
No,
have no
this is
problem with
good.
that. This is about just digesting the material in a way that you feel comfortable with. I'm sure the more that we do this,
The
maybe
more
we
it'll.
push it
Yeah.
a little bit more.
Yeah.
But if it's for right now, since we did take a technically a 2 week break because you've been busy with your other couple classes and work, then that's fine too. Okay, again, um, that shouldn't be a problem.
Yeah.
Okay.
But I'll see you again next Saturday.
Yeah. Go ahead and work through section 2.1 there.
Okay.
Try and get those problems done. Try and get some of those rest of the problems in section 1.5 done as well. So
Oh, wait.
so
Oh, I just did section 1-1. Oh, okay. Yeah, I thought.
yeah,
Oops, my mistake.
no, that's
Yeah, I'll
okay.
work through one
That's
five and
okay.
2-1.
1.5 and 2.1. You're obviously not going to do all the questions in 1.5 because we skipped that one question for completing the square.
Oh,
And
okay.
we didn't get through all of 2.1. Obviously, we only got through the kind of maybe the first half, maybe less than the first half of 2.1. But that's what you should be focusing on this week if you want to kind of do the practice with those problems. Okay.
Yeah, for sure. Okay, I
All
can
right.
do
Cool.
that.
All right.
Let me write that
All right.
down
Cool.
actually.
All
So
right. All right.
1.5 and 2.1 as much as possible.
Yeah.
Okay, that I can do.
Of And what I also would like you to do here is anything that's pretty confusing and whatnot.
Yeah.
Bring me some of those questions there next week. We can look at it together on the monitor and we can go through it carefully. If you're having a little bit of an issue with a little bit of those pesky details.
Okay.
So I'll be more than happy to kind of go over that to start, and then we can go ahead and forward from there. So it's not like so again we're going at that pace, but you're kind of there's a lot more understanding, every step of the way.
Yes.
So yeah, that's the goal, my friend. That's the goal. That's the
Excellent.
dream.
Living the dream.
Okay. Remember. Currently currently in the math phase, we're at the check down phase. You know,
Nice.
I know Tom Brady skipped that phase altogether because he just like 40-yard deep passes on a dime because that's Tom Brady. But right now we're in the rookie quarterback phase where everything is a check down or a throw in the flat, and that's all you got until you hit prevent defense in the last 2 minutes of every half. So once we get past that phase, that makes every fan very angry every rookie quarterback's year. We'll be in a better shape. I guarantee that. Let's throw to the flat. Let's throw to the flat. Let's throw to run a screen. Let's throw and run a screen. Oh look, Trubisky threw a screen on third down. Wow, didn't see that coming. You mean that the running back's in motion? Oh my gosh, didn't see that coming. Like, of course you could see that coming from a mile away. It's not hard. You can scout that 10 miles away. That's what Brady does really well. That Brady changes formations enough where you can't scout him that well. So the Bears, on the other hand,
It's unfortunate.
it's a lot of sadness, my dude. All right. Well, I'll let you go. I'll let you have some. It's noon over there, man. It's
Yeah,
nice and noon. It must be pretty nice out today, hopefully. Out in the
there
middle
is
of
lots of
Tokes.
sunshine, but I will be inside my house.
Look, I understand. No, I don't. No, I'm just kidding. I wish I could walk to the convenience store right now and have me a nice cup of soju. Okay, the get the $1 little
The one cup.
glass, the 1 cup for $1. It's the fastest way to get you drunk. You buy the $1 cup.
Ooh.
Ooh, that stuff is gross. Ooh, that stuff is terrible.
I still never actually had that.
I had it once, man, and uh, no, just don't bother. Go to. I wish you could go to an izakaya. You're gonna get better sake over there at an izakaya than you will ever get it from a convenience store. It's just bad. You go to a bar, it's just much better that way. I went to a bar one time, actually in Hokkaido, where you know that tradition where they hold your bottle and they have your name on it
Yeah.
when you come back. Yeah, yeah. I went to one of those type of bars, and so I had their local sake um, on hand for like a good week or two, and it was darn good too. I mean, strong as heck, but really darn good. Some of that sake is legit, man. Legit. Absolutely legit. Ooh. All right, man. Sorry, I'm taking up your time.
You
I
are
know
not
this is
taking
kind
up
of
my time. I'm taking up your time.
apologies. Nah, man. Of course you're not. No, you would never take up my time, dude. I want to help you out as much as I possibly can.
You've
I want to be
given me a
sure,
lot of great help so far, and I'm gonna
and a
keep
lot of
working.
and a lot of grief,
Well,
because
the,
it's
the Tyree catch did bring up some PTSS symptoms. So, David Tyree, that bastard.
I remember how. Oh my gosh, I still remember when we were both at work, and I would just I shit on you so hard
You did.
for that whole week. I shit on you so hard.
No,
I
there was some
still
some
remember that.
random gorilla attacks, if I remember correctly as well.
There were some very random gorilla attacks, yes. And there was some lots of faces of saltiness directed my way with daggers, um, rightfully pointed at my face. Um,
Oh, oh, okay.
uh,
All I have to do is breathe. All I have to
don't
do is
worry,
breathe.
that was, he made up for it later. Won more championships and became the greatest of all time.
Yeah,
So
yeah, there is that. Yeah.
that's there's that. Yeah, yeah. He didn't let one Super Bowl get him down. He basically destroyed everybody in the process. It's like, okay, fine. Scorched earth tactics. Yeah. Like to the rest of the league. Piss off. Oh my gosh. All right, man. You know it's always awesome talking with you, dude. I
Same
love
here.
talking with you. I love talking with you. I love having fun with you. Again, just let me know during the week or just text me if you have questions, just as usual.
Okay.
And
Yeah, I need to be better about writing down the questions.
yeah,
So
man. No, no, write down the questions, or if you want to text me or whatever during the week, I'll be happy to get back to you and stuff. So,
okay.
I'm always available just to help out. Okay.
Yeah, fantastic.
Fantastico, dude. All right, man. You have yourself a great afternoon.
Oh, I
Okay.
will.
All right, you better. I expect greatness, just like the Golden Boy. Okay.
Yeah,
Sir Thomas. Sir Thomas Brady, the Golden Boy. I expect greatness from you. Oh,
it will happen.
excellent. Remember, no throws across the flat.
Oh yeah,
Promise.
no, especially not near your own end zone. No. Ooh,
Very good. Very good.
yeah,
I agree. I agree with that. All right, man. You take it easy, all right?
yeah. Thank you.
We'll see you. All right. Thank you, dude. You have a great one, all right? All right. That'll end off this stream here for today. Everybody, thank you so much for coming on out here to the stream once again. I guess everybody have yourself a wonderful weekend, and we will see you later. All right. Take care, everybody. Bye.